it's Phil from Inner Wisdom again, still in my daughter's bedroom, doing these things. We'll be probably for a while yet, but here we go. So, with no further ado, let me share my screen. So, today I'll be talking about ML Ops and how to do that on AWS. Now, AWS have one of the most comprehensive machine learning stacks. It has to date been focused on two main areas: the everyday developer, so they give you some great ML services like chatbots and forecast and fraud detector and transcribe that allows cloud developers to use pre-built ML services to achieve your aims. Now, in addition to that, they also have built out Sagemaker, and Sagemaker is their platform for data scientists. And that allows data scientists to use the underlying frameworks and algorithms that Sagemaker supports on the latest hardware to produce models. Now, in the last year, AWS has focused more on what that means for the ML engineer. And the ML engineer is a new term. And with that new term also comes the other new term of ML Ops. And basically this talk is to explain a bit more what's involved in that process and how it fits together with other AWS jargon and how it also fits into this stack. So, without further ado, the main area to think about is your life cycle. And initially, that experiment bit right in the middle is a very iterative process involved in data science, and lots of the data science will take place there by data scientists, and they'll be pulling models, data in from models and changing models and experimenting with different algorithms, and eventually they'll come up with hopefully a model that proves their theorem at the start of what they're trying to set out to achieve. Now, once that's done, they'll refine that model using high parameters and maybe further looking at the data better, cleaning data better, etc. And they'll refine the model until they come up with the final model. This model may be, it doesn't need to be the best accurate model in the world. It doesn't need to be 90%. It needs to meet whatever your business needs. If 80% accuracy is good enough, then it needs to be there. And there has to be a decision took at that point on when it is good enough. And then we move to that last phase of operationalizing. And this is where ML Ops kicks in. And that's about how to take that model from the cutting board of the data science world, the notebook, and transferring that into an operational system that's a product, that solution that an enterprise can use. And that involves building out additional infrastructure, and that involves building out additional processes, and involves building out APIs and other bits of the solution that allows you to do that. And ML Ops covers all this aspect. Now, what we're going to do first of all is concentrate on the architecture, and then we're going to move on to some of the processes, and then we're going to explain some how to effectively build different parts of that. And then hopefully at the end, I will also have time to put in a bit of a demo and some automation. Now, architecture. So let's start there. This is what AWS is really good at. So focus on the web architecture framework. For those you don't know, and I'm not going to let this is a whole talk in itself. Basically, you concentrate on 5 pillars, and those 5 pillars should drive how you use AWS to the best of what you can. I'm going to focus on security and cost initially and get them out of the way with, because they're great subjects, but I can also talk a lot about them. And then as we go through the other bits, you'll start to understand how performance, resilience, and operational excellence blend into this architecture and ML way of working. Now, the best way to achieving the most well-architectured architecture on AWS is to go down their service route. That's typically what I go down, and my colleagues go down it in the Wisdom. We try to build everything as cloud native possible. That means that lots of the heavy lifting and all the maintenance stuff is AWS's burden, not ours. So use things like Lambda API Gateway, and I'll comment how to use them in a minute, and step functions for batch processing, etc. And actually, Sagemaker itself is a kind of a PaaS service, so it also blends well into this. And this is the typical kind of architecture we see from our customers. Basically, it kind of has 3 kind of core elements. One is the data lake, so in the middle, bringing data in from whatever systems you got, on-prem, click data, whatever you have, bring them into and putting them into some sort of lake house, be that Redshift, Athena, whatever. using S3 underneath to store that valuable data for you, and then processing it to produce training data sets for your models, and also to produce live hot data for when you need it, and maybe in inference. And then you have the inference process itself. So that will be API gateway Lambda, like I say. It could also be a step function triggered off something being uploaded to an S3 bucket, whatever. And then that will kick off some processes. Now, normally that all could load data from DynamoDB if you need additional hot data, or it might have enough data in its own right. It might be a complete image or something that you want to classify. So at that point, you go to Sagemaker and encode your value. So you wouldn't just send a complete image to Sagemaker, you would encode it how you want, and then send that to Sagemaker and get your classification or your prediction back of whatever you're trying to achieve, and then decode it back into a format that the business can accept. So this is generally your architecture, and this is what you'll spend some of your time building out, and the processes will sit within. So important to get this right. And now, two important aspects I mentioned earlier to get this right is security. Security is so important. Lots of the time we are dealing with personal information or financial information, individuals, and that can range from many different things. Even images of myself, that's my still identifiable from that, obviously. And my voice, running this voice back through an analyzer, you may be able to work out that it's Phil ruffling on against machine learning. That's critical. And you may be doing open banking data, bank account data, whatever your machine learning, it's normally the case that there may be some degree of PCI or personal identifying information. So security is paramount. So make sure you build security in from the get-go. So you're looking at controlling least access to your data. You're making sure that your buckets are versioned, encrypted, they're locked down resource policies that people can't get to that the valuable data accidentally. And no one wants to be one of those cases where somebody reports that your data has been exposed. And another way you can back this up is encryption, and do a lot of encryption at rest and in transit, and using custom KMS keys for those the very valuable information is also key. So even if your bucket doesn't get exposed, by accident, your KMS needs to put that another layer in to stop that being decrypted. So yes, you can get to it, but you can't actually get to the data because it's still encrypted and you haven't got access to encryption. So build that all in, and also build lots of network layer and make sure you have a segregated network that's for your data, to keep that away from the inference process per se, and spend time building out a really highly secure infrastructure that you can run this stuff on. And then lastly, it's like data privacy is a massive thing, and the most important thing I can say is only use the bits of data that you need when it comes to that PPI, PCI data. If you don't need to go near it, don't use it, don't bring it in, don't touch it, keep it away from your workload, because that's if you don't have it, then you can never be exposed to it. So take a look at that and make sure you concentrate on security when you're operationalizing your workloads. Next thing is cost. Now, if you listen to AWS and you do full TCO, it normally works out on the whole that using the cloud is less expensive than on-prem. And that's true of machine learning. If you're going to go and buy a big GPU instance, etc., that takes a lot of infrastructure there, investment and capex, and also it's one of the most changing areas. So you could build out your fleet in your data center or whatever, and within 12 months it can be more or less old and needs renewing yet again, and you may want to be able to scale lots and that kind of thing. So take a lot of look at that. Now, because costs are so important, on AWS, you also need to really keep an eye on these costs. GPUs are still the most expensive things on AWS. Machine learning workloads don't actually have any reserve instance plans or serving plans in place at the moment. So you still pay the on-demand price. So be very careful about what you use. Very much tune into how long you're training and what resources your training takes. Using notebooks is great, but make sure you turn them off at the end of the day. Really focus on knowing that price. And then when it comes to inference, really home in on the instance types you actually need and keep the minimum number in service to achieve your aims. Don't have lots when you only need a few for high availability. And make sure you refine things like instance size quite often and instance types quite often. You may think you need a bigger instance type than you need, to just keep keep it under review, and that's my. If you look after those costs, then it should be all right. Now, ML processes. ML processes and our ops processes are about building out there's two common scenarios, and we'll just go into what will happen in the lifetime of a model after it leaves that initial iteration. First is what we like to call data updates or model drifts. So these is where new data comes available to your data, and you want your data to learn on it. So if you're doing some sort of classification, and you kind of refer X number of anything that you can't classify to a certain confidence level to humans to classify for review, then what you want to do is feed that back into your model. And it may also be the case that you get more available data in one of your systems that you can train your model with. So that's new available data. You want to train on it to get your data accurate. And you can use this kind of pipeline for that. In addition, you may detect your model start to drift and it's becoming less accurate. So in both those situations, something has happened. I mean, the data needs updating on the model has changed a little bit. And you would kick off an automated process to retrain that model. And this is a fully automated kind of DevOps style process with some other significant things, and we'll come up. There is some changes and things you need to consider in the process that allows you to retrain their models and then deploy them into your production environment. And then the next kind of style is data science is still experimental. Even once you've got it live, you may want to change it. Now, a couple of different kinds of changes that may come in is you might get new data available, new features, more important features that you want to build into a model, or you want to try different algorithm. You've thought about the problem a bit more. You want to change it slightly, or change the layers, or how something works, and you want to invest a bit more time. So you want to give your data scientists the opportunity to do that. What they should be able to do is use the data, experiment, refine, come up with that new iteration of the model, and then hand it over to the ML engineer and the ML ops process. And they will then go on and then deploy that into production for you. At that point, you may want to use some sort of blue-green A/B testing to verify the impact and compare models to previously. And that's what the ML engineer needs to also take into consideration. So this process is about change at this point can happen all over the place. And it's about managing that change in a DevOps kind of consistent release policy style, because you're going to release it into production. Now, as mentioned earlier, training is quite important. Depending on exactly what you're doing, it's a kind of a cost, speed, effort scenario that you have to play off. If you've got a very big data set, it may take a long time to train on one instance, and that may be too long for what you need. If you need to retrain these models daily at a certain time, and you've got 10 minutes to retrain them, that kind of thing, then you may want to speed that process up. So you may want to look at things like distributed training. So training, splitting up the data set and training across multiple instances at the same time. You may want to look at multiple job training. So there may be instances, for example, where you want to train on slightly different things, like a certain different towns or different football teams, where generalized model might not fit what you're trying to predict. So in that situation, break up those data sets into those areas and then train an individual model on each of those areas in a multi-model kind of way. And if you're doing that process, what you can then do is start training them all at the same time across lots of and hundreds of jobs at the same time, so you get everything done faster instead of having to sequentially do it. You're doing lots of it asynchronously in parallel. So that's quite a good thing. And then if you really get into some of the complex algorithms, that you may want to look at data parallelism and model parallelism. So that's when maybe you've got too many parameters for one core to process, so you want to split across many cores, or your neural network is too dense for it to fit on one GPU, so you want to split it up into multiple different layers of neural networks to train across different GPUs. So take time looking at that as well if you get to really complicated scenarios or those big algorithms. And lastly, and this comes back again to cost, what you don't want is to your training, for example, to take a long time because it's got to download a lot of data. So you've got terabytes and terabytes of information you want to put through. It's going to take time to download that to the training instance and kick off. Now, if you're paying for a GPU, you're paying for that download time, not the GPU time, because that might, you may need that for an hour, but you're paying for it because you're also downloading it. And you're just paying for something you're not really using. So in that situation, look at seeing if you can pipeline the data instead of filing it. And that means putting packages of data in at one time. So look at pipelining the data in as another way of potentially saving lots of money and speeding up the process. Now, inference. There's many different types of inferences, and I can talk about each one all day, but the one we're going to talk about is real time today, and near real time. Batch itself is a different way, but it's important to understand how your workload is going to be used, and that reflects your decision when it comes to some of these things. You know, if it's you really only use occasional, do you really need to spend all the effort automating and training and optimizing it if it's going to be very occasional? No. You need to think about the use case, but real time, you want to think about lots of speed, response times, lots of things like that. So spend time thinking about how your model is going to be used, and that will also drive some of how your use case is going to, around MLOps is going to be driven. So it doesn't matter, training, inference when it's real time or batch, the best way to approach it is actually to separate some concerns, and that is your infrastructure concerns versus your DS concerns. Now, way of doing this is Dockerizing your ML process, your ML workload. So in your container image, you have all of your framework. So you have your TensorFlow, whatever, you have all your other native libraries, everything you need for your particular way you're designing your model. And then you run it as a Docker image on top of normal hardware. What it means is that your operational team don't have to worry about the complexity of configuring all that stuff. Plus, they might have 100 models, all different algorithms and different packages, depends all of that to deal with. You don't want that. What you want to do is run that Docker image, and the ML ops guys and the operational guys know how to run the Docker image, and the data scientists and some of the more the engineers, ML engineers, what know this stuff can focus on that data science bit. So use Docker, and this is what Sagemaker also uses behind the scenes. So when you're doing training in Sagemaker, when you're doing batch transform or real-time inference, you're actually using Docker behind the scenes. And Sagemaker is sending requests when you're doing predictions for real time to Docker. And it's like any Docker environment. You can have one container, you can have many containers. So build them out, and you can build your own. You don't have to settle with the containers available just for AWS, even though they spent time optimizing them. You can use other containers that you built yourself if you've got your own custom algorithm that's really, really secret and really special to you. So spend time on that. So using Docker is a great way to operationalize, and it's also the way that Sagemaker has gone. And this just explains a little bit more about that, is that Sagemaker, because you can do that, can allow you to run different variants into production. And this is how you can do some A/B testing. So you can send the portion of traffic to one model or the other model, and then you can figure out different endpoints. And I can go into a lot more detail about exactly what it does. But the important thing is though that it allows you to run different models, and those artifacts that it uses can be downloadable on S3, and it can run in a VPC, and it can run very securely. It can use all the KMS and all the security you need, so you have a very secure environment to run your workload. And then you can use these different models. Like I say, if you're data science and you're A/B, you can use kind of a canary style deployment to see your side by side. But even from an operational point of view, when you're deploying new iterative models, so those new incremental models, you may want to use one of these deployment systems. You might want to use rolling, so it just rolls the whole thing out, or you want to use Canary, where you take a sample and you see if it's okay, verify that predictions coming out of that are good according to the golden data set, and then run it fully. Or you want to do blue-green, where you've deployed a new one, but you want to be able to switch it back and switch it over really quickly. And Sagemaker allows you to do all this through their real-time inference endpoints. Now, the other thing is, you might not want, well, you may want to focus on how you scale. And when you get to billions or millions of predictions a day, thousands a second, it will come to a point where not one instance will be sufficient, and you want to scale out. In addition to that, you may want to scale out for high availability reasons as well, because if you have one instance of one AZ, for example, if that goes down, you're going to have time to redeploy it into another AZ or for it to start up again. So you want to just think about that resilience bit of the architect framework. You might want to deploy for critical workloads two instances of the model. And then when you're predicting millions and you're seeing scale on your workload, you want to scale up to to 2, 3, 4, many different and hundreds, potentially hundreds of instances of a model to cope with those demands. And we've seen predictions over 4 million in a day, some of our inference engines through their peak periods. So auto-scaling and high availability is very important here. Why? Because CPU matters as much as GPU. If your model is overwhelmed CPU, it will not take more requests than Sagemaker. That means Sagemaker latency will go up, and latency is one of the most key factors as well, throughput, when it comes to real-time inference. So, and this shows some runs I did, one with scaling and one without scaling. So the first one shows that once 2 instances have reached their maximum CPU usage, latency went up. When I scaled it up to 4 instances, it stayed constant. So make sure you also pay attention to that part of it. The next important aspect of machine learning ops is to monitor your model's operational aspects and its performance. Now, to do this, you need to perform a 360 view of how it's performing. The first thing you need to concentrate on is a KPI. Now, you built your model for a reason. It may be part of your product, or it may be solving an enterprise problem, or anything within your business, but it should be affecting something and contributing. And that should have some sort of KPI, something like predictions or failure attempts of invoicing, or something regarding the unable to detect images. You should be able to do some sort of KPI around the business impact on that model. And then following on from that, you want to look at the next bit of the 360 view, and that's around the model performance, how accurate it's performing, the model actual metrics itself. And there'll be ones you choose, like the F1 score, the accuracy, etc. You want to see how well your model is performing on real data versus the data it was originally trained on. And for something like that, you can use Model Monitor to look at it and detect drift when it deviates too much from before, and then the model is not predicting within the accuracy it needs to. In addition to that, you need to look at things like outliers and errors, etc., and errors and predictions outside the normal boundaries of operations. So make sure you also record them and that you're evaluating them to make sure that your model is producing the kind of outputs that you need them to do most of the time, and that you can investigate when it feels outside normal boundaries. So that's the next aspect of monitoring your model. And then it's the traditional kind of operational DevOps style. You want to look at the actual performance of the system in terms of key things like latency, throughput, and availability. And this is where some of those you have to realize some of those other well-architected pillars. And the best tool for using this, or one of the best tools, is using CloudWatch, because it has all these metrics already built in if you're using all the serverless architecture from AWS. So build out a dashboard that captures all of them. And then following on from that, you can use other aspects like X-ray to monitor inside your workload and inside those predictions. So, and this can detect bottlenecks. And if you're doing something really complicated with pandas, you can look at it here, see what's taking time, and then work at optimizing and reducing that latency for those high throughput workloads. And that gives you that 360 view of how your model is performing. And on top of that, you should put alerts to allow you to know when things are performing outside those boundaries, and when you are using too much resources, etc., and when things do go down, so you know how to correct them. And you should tier your alerts so that you are told before something even happens, so that you can get in and do preventative action, and maybe spin up new instances or redeploy an old model, etc., depending on what needs to be done to correct the operational situation. So that's also very important. Now, drift, and we spoke about drift earlier, and changing data. So there's situations where you want to go automated and situations where you don't want to go automated. For example, if you're doing an occasional workload that only has a model that needs retraining maybe once a year, there's no point doing a full automation pipeline, but you may in that situation want to make sure that the notebook or the Python scripts or the R scripts you're using are as documented as possible and turn them in more of a run book that not just the data scientists can follow, but also the other people in engineering can follow to do that kind of retraining for you. So that's one end of the scale. And then at the other end of the scale is full automation. And the AWS also supports one or two aspects that allow you to do this, and we'll cover this in a bit more detail in a moment. But it should reflect your workload. And for that high-end stuff, it'll be things where maybe the new data is coming in every week, and you need to update those models to avoid it becoming less accurate and drifting. So make sure you spend the effort proportionate to the type of workload you're going to be producing. So one of the main ways of automating is step functions, Lambda, and everything like that. And if you're from a DevOps background, you'll have the skills to do that. But there's integration with the ML services, and you also need to understand things like how training works and parameters. And that gets a bit more daunting. That's where the ML ops engineer comes into their own. To aid them in this, AWS provide the step functions data science SDK kit, and that basically allows for smooth integration with all the different ML services and data pipeline and things like Glue, etc., and also be able to deploy those models. But you can use it and construct it from Python in a data science way so that it reflects something you're more attuned to. So please take that look at that for any automation. Alternatively, Research Reinvent 2020 is Sagemaker Pipelines, which is brand new, and we're going to just take a little look around that in a while as part of a bit of a demo to understand a bit more how that does and how that compares to this. If you need any more information about any of these aspects, there's a couple of YouTubes that I've done, a couple of other blogs, etc. So please have a look at them and take a look. Now it's over to the demo, and let's look through Sagemaker pipelines and see how that is doing its model retraining. This is Sagemaker Studio, and to start playing with Sagemaker pipelines, simply create a new pipeline project. Now in here you need to select which type of pipeline you want. So once your project's created, you'll hit this screen. This is your pipelines and your repositories. Because we did a build and deploy, I have two of them, one for the build process, that is the pipeline, and one for the deploy process that pushes it out to production or through your environments for you. Now, let's look at the first stage of the build phase. It uses this pipeline. And if we dive down into it, we can see that it's run a few times already. We're going to go for the last one. This is some testing already done. So this is run through a typical process. It's done the pre-processing for us. It's done that training. It's done the verification by it's evaluated the model and checked it. And once it's happy with it, it said that it's approved. And then it will do this last stage of registering the model in the model registry. At this point, it doesn't actually deploy the model. That's what the deploy phase. But this is basically signaling that this is the latest model to go and deploy, and you can then run that in. To run that in, you basically use code pipeline, and basically that has four stages. One is the source stage. So basically, there is a build spec YAML and everything else you need for inference in there. And then when you want to deploy it, basically it runs a code build that takes that build spec, gets that latest model from the model registry, and updates some CloudFormation scripts that it will run in for you. And then the next stage, as you can see, is running in those CloudFormation scripts, and it's done a CloudFormation setup, and it's done a build. And if we look inside CloudFormation here, we can see that it's created it for us, and we can see that it's created a endpoint for us, and that allows us then to deploy the model and start doing our inference. And basically that is how Sagemaker Studio with pipelines can now deploy models using ML ops. Well, I hope you found that talk interesting, and if you'd like to know more or have any great questions, stack them up, and on the day of the Consum event I'll be there and be able to answer some of them for you, hopefully. If not, you can also reach me on Twitter or contact my colleagues at InnoWisdom, where we help to talk to you about all things ML, including how to apply ML ops to your own workloads. Cheers and bye for now.